What if I told you that right now, there's a single machine worth $400 million that controls the entire future of technology? And what if I told you that without this one machine, your smartphone, your laptop, even the internet itself, none of it would exist, right? This isn't science fiction, this is the most important machine you've never heard of. And the story of how it came to dominate the world is absolutely mind-blowing. Hey everyone, I am Rishi Panchal and we are diving deep into one of the most fascinating tech wars in history, the battle for lithography supremacy. This is the story of how a small Dutch company born in a leaky shed completely destroyed Japanese tech giants worth billions. So grab your coffee, hit that subscribe button, and let's get into it. So first, let me blow your mind with what we're actually talking about here, right? Picture this. Inside an ultra-clean room, cleaner than an operating theater, sits a machine the size of a double-decker bus. This thing costs $400 million and had to be shipped in parts on 3 Boeing 747s. No, I'm not exaggerating. This is the most complex and precise machine humans have ever built. But here's the crazy part. All it does is print patterns of light onto silicon wafers. That's it. Sounds simple, right? But without this lithography machine, literally nothing in our digital world would exist. Now, here's where it gets interesting. For decades, this market was completely dominated by Japanese companies. We're talking about Nikon and Canon, names you know, right? In the 1990s, these Japanese giants controlled over 75% of the global market. They were literally the gatekeepers of the future. So how did all this change? How did a tiny Dutch company not only challenge but completely crush these established giants? This isn't just about business competition, this is about two completely different philosophies clashing head to head. Let me take you back to the 1980s, the golden era of Japanese technology, right? Japan's economy was absolutely on fire back then. Their semiconductor industry was the crown jewel of this economic miracle. By the late 80s, Japan's share of the global semiconductor market had shot past 50%, completely overtaking the United States. Can you imagine that? By 1989, 6 out of the world's top 10 semiconductor companies were Japanese. This dominance was built on something called keiretsu, basically huge vertically integrated business groups working closely with strong government support. Companies like Hitachi, Toshiba, and NEC didn't just make chips, they built entire ecosystems, right? Every single step was handled in-house or tightly coordinated with partners. And at the heart of this ecosystem was the lithography machine. The key technology back then was called the stepper. Think of it as a super advanced slide projector, right? It reads the master blueprint for the chip circuit and projects tiny images onto silicon wafers, stepping from spot to spot. Now, when it came to precision lenses and stable stepper machines, nobody, and I mean nobody, did it better than Nikon. They leveraged decades of top-notch camera and lens-making experience. The Japanese government even explicitly directed Nikon to break into lithography tech, seeing it as crucial to Japan's economic ambitions. By the mid-1990s, Nikon and Canon together controlled 3/4 of the entire lithography market. They seemed absolutely unbeatable, right? But here's the thing. This fortress-like setup actually planted the seeds of its own downfall. While Nikon was perfecting their machines internally, something revolutionary was happening elsewhere, right? Instead of the traditional step method, what if you could scan the pattern across the wafer like a modern office scanner? This step and scan method had two massive advantages. First, it allowed for larger chip designs without needing impossibly huge equipment. Second, by scanning the image across the wafer, it averages out tiny imperfections in the lens system, boosting chip uniformity and cutting down defects. This wasn't just an upgrade, this was a fundamentally better design. The company betting everything on this approach was ASML, the underdogs from the Netherlands. And let me tell you, they didn't start out glamorous at all, right? They split from Dutch electronics giant Philips in 1984, and their first office was literally a leaky shed in Eindhoven. For years, they struggled hard, running out of money, few customers, brutal competition. But they had one crucial advantage. From day one, they partnered with German optics expert Carl Zeiss for their lens systems. This reliance on outside partners, born out of necessity, later became the defining part of ASML's DNA. Their breakthrough came in the early 1990s with the PAS 5500 platform, a Stetson scan system that was more efficient and had better resolution than competitors. This machine finally won them major chipmakers outside the Japanese ecosystem, including a key early order from the rising Taiwanese foundry, TSMC. Now, Nikon wasn't completely clueless about this new tech, right? They eventually developed their own scanner in 1995. But here's the problem. Their main focus and most of their R&D efforts were still on mature, profitable stepper technology. Classic innovator's dilemma. By the early 2000s, the entire semiconductor industry hit a massive wall, right? To keep shrinking circuit sizes according to Moore's law, chipmakers needed shorter and shorter wavelengths of light. But making reliable deep ultraviolet lasers was insanely difficult and expensive. The solution seemed impossible until a brilliant Taiwanese engineer at TSMC named Bern J. Lin had a crazy idea. What if you dropped a tiny drop of ultra-pure water between the final lens and the silicon wafer? Sounds simple, right? But this was genius. Light bends when it passes from one medium to another. By replacing air with water, which has a higher refractive index, the light bends more sharply, effectively boosting the lens's power and letting you print much finer patterns. This was immersion lithography, and this became the real turning point in the battle. ASML saw this as the future and went all in. They deepened their partnership with TSMC, who desperately needed the technology. In 2003, TSMC and ASML placed the industry's first order for a production-ready immersion lithography machine, with delivery planned for 2004. It was a huge gamble for both sides, right? But Nikon, they played it safe. As the market leader, they saw this new technology as risky, worried about bubbles, contamination, and defects from watermarks. Instead, they hedged their bets by developing a proprietary method called Polano that used polarized light to boost image contrast without needing water. They believed they could push the existing dry technology further, a conservative, gradual approach that had worked in the past, but that was a fatal miscalculation. Here's where ASML's unique design philosophy gave them a crucial edge, right? Their twin-scan dual-platform system was brilliant. It measures wafers on a completely separate dry platform, then moves them to a second platform for the wet exposure process. This clever setup isolates the complex immersion process, minimizing contamination risks and significantly boosting yield. Nikon's rival, Tandem, the platform took a different approach, combining exposure and calibration stages, but it turned out to be less efficient and ultimately unsuccessful. The market's verdict was swift and brutal. In 2006, the first full year of immersion lithography, ASML grabbed an impressive 72.4% market share. By 2011, that number had shot up to a staggering 82%, while Nikon's share plummeted to just 18%. The race was basically over, right? But ASML's win wasn't just about picking the right technology, it was about how they developed it. This marked a fundamental shift from the old supplier-focused innovation model to a customer-centered, collaborative approach. ASML wasn't just selling machines. They were working hand in hand with customers to develop solutions for their most critical challenges. In an increasingly complex industry, this collaboration proved to be a complete game changer. Even with immersion lithography conquered, Moore's law demanded an even bigger leap forward, right? The industry needed to move to extreme ultraviolet light, EUV. But this was a completely different ballgame. EUV light has a wavelength of just 13.5 nanometers and carries so much energy that it gets absorbed by everything, including air and even the highest quality glass lenses. That means EUV machines have to operate in perfect vacuum conditions. They can't use lenses at all and must rely on a series of flawless multi-layer mirrors. The light source itself is a technical nightmare, using high-powered industrial lasers firing 50,000 times per second at tiny molten tin droplets to create plasma that emits just enough EUV light. The technical hurdles and expected costs were so massive that after initial research, both Nikon and Canon officially gave up on their EUV projects, deeming them commercially and technically unfeasible. ASML pushed on, but by 2012, even they were on the brink of collapse. The R&D costs had reached billions of dollars, with no clear end in sight, right? So their leadership took an unprecedented step in manufacturing history. ASML went to their biggest customers and made them an offer they couldn't refuse, right? The world's top 3 chip makers, Intel, Samsung, and TSMC, invested over 5 billion euros directly into ASML. They provided 1.4 billion euros in non-refundable R&D funding and collectively bought 23% of the company's shares. Just think about it. These customers became co-owners and co-investors of the very lithography machines they desperately needed to buy. It was the ultimate expression of ASML's collaborative philosophy and a brilliant, symbiotic solution that solved the problem no single company could handle alone. For Nikon, this marked the end. Stuck with a traditional, conservative company structure and lacking the global, trust-based partnerships ASML had built. They simply couldn't match that level of shared investment and risk. They had no choice but to give up on the cutting-edge market. The war was over. ASML had won a complete victory, right? Today, ASML holds a total monopoly on EUV lithography machines, the only tools capable of producing the world's most advanced chips, right? A single EUV machine costs over $200 million, and the latest high-NA models cost nearly $400 million. And here's the irony. All the world's leading chip makers have to buy these machines from the very company they helped create. But was Nikon's failure entirely their own fault? Or was it a sign of deeper issues? The 1990s and early 2000s were Japan's lost decade, a period of economic stagnation that bred a culture of corporate risk aversion. The entire Japanese semiconductor industry failed to adapt to the new fabless, foundry-based model reshaping the global landscape. There's also the camera angle, right? In the early 2000s, while the lithography battle was heating up, Nikon was in its heyday with digital photography. Their digital SLRs were flying off the shelves. Did this steady, reliable profit make them complacent about riskier ventures? There might even be a geopolitical angle. Some believe U.S. policies that restricted Japan's access to foundational EUV research inadvertently favored the European company ASML. ultimately, Nikon's failure wasn't due to one bad decision but a series of interconnected missteps rooted in their corporate DNA, right? Their conservative culture made them choose safe dry lithography over riskier immersion technology. Success in cameras and Japan's economic stagnation kept them financially conservative. Their isolated, self-reliant structure made collaborative financing impossible. So how did Nikon fail? They failed because they were busy perfecting the last war while ASML was preparing for the next one. They focused on self-reliance instead of open global collaboration. In the end, the world's most complex machines became so complicated that no single company or even country could build them alone. ASML didn't just build better machines, they created a smarter business model with an open, global, risk-sharing network. The result is the world we live in today, where a Dutch company holds an absolute monopoly over the technology needed to build the future of computing. This has made ASML one of the most critical geopolitical choke points on Earth, right? The tech war between the US and China is, in many ways, a battle over control of ASML's machines. Today, the fate of global technological progress partly depends on decisions made in a small Dutch town. Closing the lithography wars might be over, but their lessons still resonate powerfully, right? They remind us that in technology's ruthless march forward, no empire lasts forever. Sometimes, those who win the future aren't the strongest or most precise, but those willing to share risks and humbly seek help. What do you think? Could Nikon have done anything differently? Drop your comments below and let me know your thoughts. And if you enjoyed diving deep into this fascinating tech story, make sure to follow me for more such content.